heard that all railway operators have sometimes some issues to know where their trains are, on the tracks of course, but where are they located? So this is a nice presentation going to be demonstrated and explained by Mrs. Sophie Glevarec from the company X-Blue, specialized in hybrid localization services and systems.
Hello everybody, so I am a technical engineer and in charge of developing the inertial navigation system for railway for X-Blue, my company. In fact, we are part of many domains of application with our inertial navigation system, and we have many questions of how to help railway undertakings on to reduce infrastructure, cost and maintenance with a new technology we promote, which is hybridization with our INS, with GNSS and other parts of new technology. Next slide, please. So a short brief overview of the company. We have an headquarters of Saint-Germain-en-Laye, which is near Paris, and in fact, we are more than 20 years in navigation system with many domains of application, and we are part of railway application for mainly, mobile mapping, maintenance, meteorology system or ground truth with our INS, and now we are think about to use it with direct navigation and to bring a good break of localization system. So we are on a project as Anan Aitnoun present this morning, up to 2 years ago with SNCF on that. So next slide, please. Yes, thank you. So what is a INS? Inertial navigation system is based on in fact on 6 degrees of freedom, 3 accelerometers and 3 rotation made by gyrometers. The gyrometers we built in X-Blue is based on fiber optic gyrometers. And with this IMU, of course, this is not enough for navigation. We have had to add a navigation system, robust algorithms dedicated for providing high rate and low latency, because it's complete in the same solid, 3D position, georeferencing position, and also speed. So all of this could be provided for a good localization position on board on the rail. The plus of this technology is that it is fully embedded inside the vehicle, so it knows very well all the orientation of the vehicle and all the speed and all the motion of the vehicle. So this helps us, in fact, to put many algorithms, and some algorithms dedicated with this kind of vehicle, which is a train, because it's a one-guided vehicle. So we develop also as well some dynamic models specific for the train. So this is part of the INS. Of course, the capability of the algorithms we have is possible to hybrid it with external sensor, because of course nobody is perfect, so this system is drifting a little, and then we have to fix sometimes position, and we can be helped by that with the GNSS, so by the satellites, and also by the cartography, which is not environment dependent, different of the GNSS. So this is the purpose of the presentation is to present you the results you have with this hybridization on the INS, with the hybridization of GNSS parts, and also with the cartography we work with SNCF right now. Okay, so just a short brief, an overview of the internal system embedded. In fact, we do not only deliver IMU and navigation unit. We deliver, in fact, a kind of fusion algorithms with all of these external sensor. In fact, it is specific filters in which you have IMU sensor, internal sensor we manufacture, like accelerometers and gyrometers. And in the other side, the external sensor could be used and GNSS, map, etc. So all of these are well balanced with complete error model of the system. So we manage this as well in order to deliver INS data at the output, and also for sure the standard deviation, which is a statistical error view, which must be covering and precise as well for having a good error at the end. So this is this technology, in fact, what we will see after the results we have, it's 100% available data, because at each time 100 Hz or 200 Hz, they deliver position and speed at each time with full availability. Okay, next slide, please. Okay, a short brief of the kind of technology, in fact, we use. We use here gyrometers by fiber optics. In fact, at XBlue, we are found on technology, but we are also a manufacturer. We manage as well from the beginning of fiber optics. Fiber we manufacture to make the coils and then to make the gyrometers. So we have a photonics division up to final integration and qualification. This is the same with accelerometers. We develop the wafer, we implement it, and we make the MEMS accelerometers. So we make all the AIMU sensor in our plant, and we also develop all the algorithms in order to have a complete control from A to Z of the system. So here there is some pictures of the photos we have at Brittany in Lannion, in fact, and the plant. One people is going to make a coil here. Checking a coil or a wafer for an accelerometers, in fact. Next slide, please. Thank you. So, what is the purpose right now? It's a test we carried out with SNCF. In fact, we are part, and we have leader, in fact, of the project Log4Rail. Will be ended at the end of next year. And we develop for that a rack in which there is one of our INS. In this rack there is an embedded PC capable to register the data, check it, and after send it via 4G link to a data server, in which we can then at lab have the time to analyze the data and explore it. So this rack is fully certified for railway application, and we already installed 4 of them. 2 are installed in area line C and line D right now, and TGV. So right now we are up to 20 kilometers and more than 2,000 hours of data register. So it's a quite big data, and we work also on that to make automatic tests because it's quite a big data analysis of this, and we have again 1 year more to test, so it's huge data to collect and to analyze and to make some automatic analysis. So next slide, please. So what is the results? The result I presented is hybridation with GNSS and hybridation with cartography. Here, in fact, we have a test not very helpful for GNSS because it's a suburb of Paris and Paris, Intramuros. It's area line C. It's very, we note that the GNSS in that part is very masking area because of tunnel, because everything. So roughly there are less than 60% of availability of this sensor. So for sure, what we see in red, this is a GNSS, and what you see in blue, this is a INS, complete final solution. So for that solution, for sure, we have 100% available in performance. In fact, we have also on this curve, you see, we obtain better than 10 meters at about more than 95% of data collected. So it's very relevant for SNCF at this stage for a non-safety use. So it's very interesting and impressive at that stage right now. Of course, we obtain this result because we have good algorithms inside and we have a dynamic model vehicle inside which help the performance. So, of course, this is the first result. We have hybridization with GNSS, but we can do more, in fact. And we develop, and we have a patent on it, with cartography hybridization. So in the next slide, you see the same kind of surround environment, which is area line C already. And the concept here is that we know the cartography, so we know the line of the train, and then we can analyze it and put some kind of virtual balises, but we can some fixed position at a located georeferencing point, very interesting, which is a point of interest for the inertial sensor detection. And once we put this point of the map, we have another map with this point, georeferencing point for INS, and we send it to the INS, and then we can carry out the line. And at each point, the system is encounters this fixed point. It can take that as it was for a fixed point external system. And then you can see in the blue line the results we have for the run, which is very interesting at that stage also. We have again 100% high performance fully available with less than 1 meter horizontal RMS value. And you see in one another thing it's interesting is that in green you see the standard deviation, and you can see that it's 1 sigma, and you can see that it's always covering the error, which is very also interesting, and the robustness of the algorithms embedded demonstration. Upper you have the speed, because another part of the INS which could be very interesting is the speeds that generated, and you see the speed of the vehicle here. It's RER, so yeah, there is many stops, and the level of speed also could be useful for the localization for sure. Okay, the last slide is the same picture with hybridization with cartography, but the first result we have on TGV. TGV, it's also very interesting to explore, because there is a high, of course, high level of speed and low level, and the trajectory is very specific. So you see in the speed here up to 300 kilometers per hour, and all during the trajectory, and the speed profile, which is very interesting for us. And at the bottom, the results we have with the same hybridization with the cartography, which is quite interesting also. We have roughly RMS of 5 meters horizontal position, so it's quite interesting also, this one. Okay, so this is the end of my presentation. Thank you. The next step for us is to collect again and again data, and to again and again have a rough and very important statistical analysis in order to demonstrate that the system is totally robust to the concept for the localization without many infrastructure, in fact. And the next step after is to transfer that on a safety purpose still for implementation. Thank you.
Well, thank you very much, Sophie, for this nice presentation. So maybe may I call for a question from the assembly here? Well, I'll just get one question from the YouTube platform, because this is a live streaming as well on the YouTube. And the question is about the localization system here. Would it be able to replace all the equipment on board a train, actually on the actual train, like the speed sensors, like the radar systems, in order to find the exact localization of trains and to improve the number of trains traffic on the line.
Yes, this is one of the objectives, for sure. But we know that we are an industrial, and we know that the step is quite long to have the level of safety expected for this. So, but the proof of concept and the demonstration of performance we have right now is very interesting, and we are in the good direction.
And this is a great example where the aircraft, military, and space industries are at the service of the railway industry for the next generation of signaling systems. Then, thank you.